All right, AP Chemistry, we are going to continue our problem sets with 6A. This is lesson or day 1819, and this is on solution stoichiometry. Okay, so a solution is made by dissolving 13.5 grams of glucose. There's the formula. In 0.1 kilograms of water. What is the mass percent of solution of solute in the solution? So we're going to go ahead and write the formula for mass percent. And I recommend you always do this. That way you end up memorizing formulas. Okay, so there's the formula. So what's the solution? It's grams of glucose plus grams of water together. So let's go ahead and write that out. Okay, so again, this has a plus sign in it, so it's not just a nice clean left to right single equation. So we have to see what we know here. So what we know is grams of glucose. We're given that already. So we're going to go ahead and write that over here. Okay, so right here. So that's going to be okay, there it is. So this will give us the mass percent based on this solution to that to that. The only thing we don't know is grams of H2O, but we know kilograms of H2O. So that's a pretty easy conversion. So we'll come over here and do that. We'll do that over here. And the relationship is and that's true of anything. I'm here to separate that. So that's how many grams of water we have. So we can now simply make that substitution there. So I'm going to come over here, try to squeeze it in here. Okay, there it is. So you're going to add 13.5 divided by 13.5 plus 100, and then multiply that by 100%. Okay, and that gives us an answer of 11.9%. So by mass, by weight, 11.9% of this solution is glucose. That means since that's the only solute, if you were asked, that would mean that 100% minus that number, which would be 88.1%, would be water. So this is glucose, and the other 88.1% would be water. Okay, this should be 6B, so this is one for you to do right there. All right, and we're going to go on to some other problems, another problem set that is not an A-B set. It has some multi-part problems here. BLB, by the way, is your book, is your textbook. So let me be clear what we're doing here. We're doing problems from page 544 of a college textbook. These are not meant to be easy problems. They're meant to be problems that are about as hard as any that you will see on the AP exam, and I'm hitting you with them early so that you have 7 months to practice these. So if these don't come through the first time, they're not supposed to. They're supposed to be a challenge for you to understand, okay? So don't get frustrated by these. All right. So an aqueous solution of hydrochloric acid, HCl, contains 36% HCl by mass. So that's a mass percent. So you know, even though the words mass percent are not used, you have to recognize that's what that is. Calculate the mole fraction of HCl in the solution. Okay, so what we're going to do then is anytime we have a mass percent, we get to pick. Remember, mass percent So in mass percent, we get to pick the mass, and we choose to pick 100 grams. So that means it's going to be 36 over 100. So you're going to start with 36 grams, and I'm going to use every bit of page that I have here. So 36 grams over 100 grams, let me be more specific, of HCl over 100 grams of the HCl plus the water, the solution. Alright, okay, so that's what you're starting with. You want to get to mole percent, so you want to get to, here, you want to get to some number. It's not mole percent, it's mole fraction rather. Mole fraction is what we're looking for. In solution, because we're going to have to break this out, we're going to write it like this. Okay, and okay. Okay, so this problem, we're going to take the top part. We got to get from grams of HCl to moles of HCl. So that's a molar mass conversion. So I am going to come down here and calculate that for HCl. Way down here, I want to use all the space on the page. Okay, and that comes out, you add 1 hydrogen to 1 chlorine, you end up with 36.46. Okay, so that's HCl. Alright, so that you're going to turn it into your 2 conversion factors. So we're going to come down here and take the top part of the problem first. We're going to break this up because we can't do one long equation when you have a plus sign stuck in there. So we're going to do the top part first. And we get 0.99 moles. Okay, so that is going to fit into there and there. Now we need to know the moles of water. Well, let's come down here. Let's take the bottom part. So let's write out explicitly what solution is here. It's 100 grams. Okay, so it's 100 grams of the HCl plus the H2O. Well, we know that 36 grams is the HCl. So what we have remaining is 64 grams of water. Okay, so now we're going to take that and convert it into moles of water. And I think you all know the molar mass of water by now. If you don't, you will. You weren't asked to memorize it. But okay, so 64 times 1 divided by 18.2 is going to give us the moles of water. And that gives us this. Okay, so that number is going to go in there. Alright, let's see if we can squeeze them all in up here. So, moles of HCl is there, so it's going to be... Okay, so take that and divide it by those two added together and you'll have your answer. And that's called chi, and it's dimensionless. There's no dimension, no units to it. I'm going to get 0.2. I'm going to round the second digit, significant figures to 2 here. 2. And that's it. So it's roughly 1/5. Roughly 1/5 is hydrochloric acid. Alright. I used my entire space to do that, so I'm going to do this on an attached piece of paper here. And it's asking the molality of HCl. Okay, so part B is asking for calculate the molality of HCl in solution. So what you want to do is start off by defining molality. Go back to your concentrations sheet. Okay, and molality is moles of solute over kilograms of solvent. And that's almost always water in this case. That should, of course, be in parentheses. So that's the formula we're going to go use. Okay, so there it is, moles of HCl over kilograms of solvent. There it is, so that's molality right there. All right, so what do we have? Well, we already know moles of HCl, And we know grams of H2O. So the only conversion we have to do is make that into kilograms. Okay? So since we already know we figured out grams of H2O right there. We're going to change that to kilograms. So that's the one calculation we have to make. Okay, and we're going to get 0.064. So now we can just come up and plug those numbers in. We have 0.99 moles of HCl. Okay, so over here, 0.99 for moles of HCl. And there's our kilograms of H2O. Okay, and we just do the division on that. And that equals, I'll write it up here, up above, 15.5 molal. Okay, this divided by this is 15.5, and that's molality. So that's 15.5 molal. So that's your final answer for 7.7-1B. So again, this is a very serious problem deep into a college chemistry book, okay? This is not going to come to you the first time. You practice these for the next 7 months, okay? So keep that in mind. Okay, we move on to 7-2. Okay, this is a lab problem. This is a problem. This is very likely to be something they could ask you on the AP exam, because it's basically asking you as a student, you go into the lab storeroom and you need to get a certain number of grams of sodium hydroxide. You need to get enough to make half a liter, 0.5 liters of 3.2 molar aqueous NaOH aqueous solution. So how many grams do you have to use? So again, it's a matter of knowing how to set up a problem and practicing it. Again, don't feel frustrated if you don't get these right away. So it's going to be grams of NaOH. That's what you're trying to find. How many grams of NaOH? Okay, and again, you have two things. You have a volume of liters and a molarity, capital M. And you may say, I'm not sure which one to start with. It doesn't matter, but you want to start with the molarity in this case, and the liters is going to come in to help you make conversions later on. Remember, as long as your units cancel and you end up with grams of NaOH, it doesn't matter which one you start with, but we're going to always start in these problems with molarity. So I'm going to come way over here. I'm going to write that. Okay, and again, as long as it's not a mass percent or mole fraction problem, you're not going to have any plus signs in this one. So this can be one continuous equation. Okay. All right, so we need to get from moles of NaOH to grams of NaOH. And you know what? I'm already looking at this and thinking I didn't leave myself enough space. So I'm going to make this line kind of small, actually. Okay, so we need to know moles of NaOH. You calculate that, and I'll write it down here. So that's the molar mass calculated off your periodic table for 1 sodium, 1 oxygen, 1 hydrogen. So which one goes on top and bottom? Again, we're only dealing with the top right now. Top to top. So we need to get on the top from moles of NaOH to grams of NaOH. And then on the bottom, we need to go from liters of solution to nothing. We have nothing in the denominator. Okay, and that's where that 0.5 liters is going to come in later. Okay, so this one, a lot of times we want moles on top, but not this time. We want to end up with grams, so it's going to be this. Okay, moles of NaOH, moles of NaOH. All right, and that cancels. So now we have grams of NaOH on the top. That's what we want, so we're done with the top. Now the bottom, we have liters of solution. We have nothing here, so this one's pretty easy. It's going to be this is the amount of solution. Read the entire phrase here. 0.5 liters of 3.2 molar aqueous solution. So it's saying you have 0.5 liters of solution, not of NaOH, not of water, but of solution. So that's going to cancel out with liters of solution. And you don't have to have anything on the bottom. There's no rule that you have to have a denominator there. So liters of solution, liters of solution. So everything on the bottom's canceled out. The top is already good. So it's going to be 3.2 times 40 times 0.5. Again, a little mental math. Half of 40 is 20. 20 times 3 is 60. 1/5 of 20 is 4. So, but let's do it on a calculator. 3.2 times 40 times 0.5, and that's going to give us 64. Okay. So I actually did have more room than I thought I needed here. So let's put the equal sign. And that's going to be 64 grams. So you're going to have to go into the storeroom and get 0.64 grams, or get, 64 grams of sodium hydroxide in order to make this, which you were asked to make. Okay? Again, a problem that you practice in the future. Okay? Let's keep going. Okay, we're now 7.3. I'm going to scratch 7.3 for a variety of reasons. I'm just not going to do that right now. I'm going to move on to 7.4. Okay, so it says you have a 750 milliliters of a 1 molar HCl solution. You would like to dilute this to 0.6 molar. How much water should you add? So going back to lemonade, you make lemonade. You put the powder in, you put the water in, you stir it, you drink it. It's too strong, it's too sweet, it's too syrupy. So this is called a dilution problem. So it's called a dilution problem. You're going to dilute your lemonade and make it weaker so it tastes right. Okay, so it says you have 750 milliliters of 1 molar solution. You would like to dilute it to 0.6 molar. How much water should you add? Okay, so what the dilution formula is the mass, the molarity before dilution times the volume before dilution. So that's M1V1 equals the molarity after dilution times the volume after dilution. It looks almost like a formula from physics, but it has nothing to do with that. So this is actually an easy problem if you recognize that it's a dilution problem. They very likely could give you one of these on the AP because it's a very simple problem and you could solve it quickly. All right, so the molarity before is 1 molar. And the volume is 750 milliliters. Now, as you're going to see, things are going to cancel out here. So you don't have to convert to liters here. You'll just express, well, we'll see how it works. Okay. Now, you want to dilute it to be 0.6 molar. And you want to know what volume that would be. So as you can see, that's a simple algebra problem. You're going to get your volume in milliliters, but that's fine. Okay, so we're going to rearrange this and write it like this. I'm going to divide both sides by 0.6. Okay, so molar cancels there, and you're going to get a volume in milliliters. So it's 750 divided by 0.6. And that gives us 1,250 milliliters of the overall solution. Okay, so that's what your volume has to end up with, but that's not the question. It's how much water should be added. So this is what you want to end up with, and this is what you started with. So your answer is going to be the difference between those two. Be careful when you read a problem, you're sure what it's asking for. And that's going to equal 500 milliliters of water. That's your answer. That's what you have to add to dilute that solution to go from being 1 molar, which is more concentrated, to a less concentrated value of 0.6 molar. All right, we go on, and I am going to, just for the sake of time, I'm going to eliminate 7.5 and 7.6 from this assignment. Again, these were some of the most difficult problems you'll see in this class. You're not expected to get them overnight. Again, this is a textbook problem from chapter 13 of your college level textbook. It's not supposed to be easy. It's supposed to be college level, AP level. Let's look at this one. This is a good one to do in the future sometime because it gives you some basic data and asks you for molarity, molality, mole fraction, and mass percent. So it asks you for that's the whole bunch of them together right there, okay? I'm going to skip that one right too for time. So work on these, and I'm going to give you an extra day on these, and go ahead and work on these tonight, and we'll talk about them in class today. All right, we'll see you in class.